This is hydrogen. It's the first element in the periodic table and the lightest, while also being non-metallic and non-toxic. It also makes up a staggering 73% of the visible universe, making it the most abundant element. But what is a hydrogen fuel cell? Well, it uses the chemical energy of hydrogen to produce electricity, only leaving behind the electricity it produces, water and heat. No CO2 is produced. So how does it really work? Oxygen from the air is supplied to the negative electrode while hydrogen is supplied to the positive. At the positive electrode, hydrogen is split into a proton and an electron using electrolysis. Now, while the H+ can pass through the electrolyte, electrons cannot, so are forced around through the circuit, which creates current and electricity. Then at the negative electrode, oxygen combines back with the protons and electrons to form water. This diagram displays an example of how this would fit into an aircraft. The liquid hydrogen is converted to electrical energy in the fuel cell, which is then used to power the electric motors and propellers to provide thrust. Of course, this liquid hydrogen has to be stored somewhere, and as hydrogen is liquid at minus 250 degrees Celsius, it must be in pressurized containers. Unfortunately, due to the large size of the containers, the fuel cannot be stored in the wings as normal, but must be stored in the main body of the aircraft, taking up passenger space. Despite these high-tech containers, the energy density of liquid hydrogen is still nearly 4 times lower than jet fuel, so bigger tanks are needed for the same amount of energy. Now the storage has been covered, how will these aircraft be powered? Original jet fuel engines work by compressed air being ignited with fuel and the exhaust gases pushing out the back, creating thrust. As this uses combustion, which is not as green, electric motors are used, powered by the electricity from the fuel cells, which spins the propeller, providing thrust. There are upsides to this, having a much higher efficiency and being smaller in size, but also quite a few downsides, including a lower cruise speed and lower thrust, making them very inefficient at high speeds. Finally, how do we get the hydrogen fuel to power these systems in the first place? Despite it being the most abundant element in the universe, hydrogen is almost always found in compounds such as water or methane, as it's so reactive. So it needs to be split into hydrogen, and the two main methods are gasification. This reacts organic matter with oxygen without combustion at over 700 degrees Celsius to form hydrogen and carbon monoxide. This carbon monoxide can also then be reacted with water to form more hydrogen, although this does result in carbon dioxide also being produced, which is a greenhouse gas. The second method is electrolysis, which uses 2 rods placed apart in water. A current is then passed between them, which causes the water to split and form hydrogen. So what companies are currently investing? Well, actually quite a few, namely Airbus, zeroe, Boeing and Rolls-Royce. Airbus have designed Aerostack, a hydrogen fuel cell powered propeller. Rolls-Royce have converted a jet engine to a hydrogen combustion engine, which could be used in combination with fuel cells to create a hybrid aircraft. Boeing have flown a small 2-seater aircraft called the Diamond DA-20 that ran on fuel cells back in 2008, whereas in 2023 zeroe have also flown a Dornier 228 using a hydrogen electric powertrain, and their aim is to have a certifiable system by 2025 to power aircraft carrying 19 passengers roughly 560 kilometers. This is also their draft timeline until 2040. So, what are the benefits? Well, hydrogen is renewable and abundant, and it will never run out in the future. It also emits no greenhouse gases apart from water vapour, with the majority being recycled in the water system of Earth. The electric motors also produce no noise or visual pollution and no nitrogen oxides. Liquid hydrogen also has 3 times higher energy per mass than jet fuel and would refuel in a similar manner, so less weight meaning higher efficiency. But there are also downsides. For example, hydrogen needs to be extracted using energy which could come from non-renewable sources such as fossil fuels, which is bad for the environment. As it is an emerging technology, a large investment is needed for it to become a reality. Due to this lack of investment in infrastructure, currently hydrogen fuel is 4 times more expensive than jet fuel, increasing the cost to the consumer considerably. And finally, electric propellers are very inefficient at high speeds as they struggle to push air faster than is coming to them. What could be the ideal timeline? Well, currently in 2023, a few prototypes are being designed and tested, as mentioned earlier. By 2030, the technology should have improved to a point of commercial viability. By 2035, the first commercial hydrogen planes should be put into service, and by 2040, older jet aircraft should begin to be phased out and instead replaced by hydrogen-powered aircraft. Then finally, by 2050, half of aircraft should be hydrogen-powered, whether that be by hydrogen combustion or what this video focuses on, hydrogen fuel cells. But is this feasible, and is the technology really worth investing in? A compromise may be needed with hydrogen and with the use of hybrid planes. These are use electric motors and fuel cells for takeoff and landing, which are quieter and more efficient at low speeds, but when up in the air and travelling at high speeds, hydrogen combustion jet engines are much more efficient. They can also both be powered by the same reserves of liquid hydrogen. Like all technologies, for example electric cars, they become cheaper, better and more accessible with more investment and more money. Another table from ZeroE shows the comparison between the different powertrains and why H2 electric is so promising for the future. So, do you think this is a worthwhile investment of the benefit of the environment and the longevity of aviation, or a waste of innovation?